Well, hello there. Today we're going to answer the question of how do we translate the parent functions. So of all these parent functions, we can apply all these transformations to them to change them, right? Like transformers change. And so today we're going to focus on translations, which are just sliding them. And we're going to slide them up or down or left or right. And we do this with these values h and k. And let me show you what those are. All right, so here we have all the parent functions that we've seen before. And I can write all of these with these three letters, a, h, and k. So an absolute value would be y equals a times the absolute value of x minus h plus k out here on the outside. The quadratic is y equals a times x minus h squared plus k, and then it just keeps going. Square root, you might be able to guess, is a square root of x minus h plus k, and so on. So we have all of these that are basically written the same way. Whenever we get down to linear functions, we can also do that. Y equals a times x minus h plus k. Now, unlike these other functions where we're taking the absolute value of x minus h, or we're squaring it, or we're taking the square root, with a linear, this is just set up to where you could distribute the a, and this would end up at y equals mx plus b. Okay, so today we're going to only focus on the h and the k. We're going to start by focusing on the letter k. This shifts graphs up and down. K is always the constant hanging out on the outside. It's not attached to the x the way h was. So, like for instance, if we had y equals 3 times x minus 2 squared plus 3, what would the value of k be? Well, k would be this 3 that's just hanging out. If k is positive, the graph will shift up. If k is negative, it'll shift down. Okay, and we call these things vertical shifts because they're up and down. So let's look at an example. All right, so first we're going to look at f of x equals the absolute value of x minus 3. So let's identify a couple things first. Let's identify the parent function and its translation. All right, so the parent function of this will be absolute value. We can just put absolute value like this. Now this minus 3 that's hanging out outside of the absolute value sign, that's a k value. So our k is negative 3. That's going to make us shift down 3. So the steps that we want to take, we're going to plot the parent, and then we'll just shift down 3. All right, so our parent functions we should have memorized. The absolute value of x hits the origin, and then it just goes in this V shape. Okay, 1, 1, 2, 2. Like this comes from the absolute value of negative 2 is positive 2. All that for the parent function. Now, to find our new graph, I'm going to shift each of these points down 3. So 2 becomes 1, 2, 3. Now I have the point negative 2, negative 1. And every point gets shifted down 3. And now I have my translated function. All right, so this time you try. We have f of x equals the square root of x plus 2. So name the parent, name its transformation, and then plot the parent, and then transform and plot the new graph. All right, go ahead and press pause, and then we'll get back together in a moment. All right, so the parent function was a square root. The transformation was up 2, so I plotted the parent function and shifted each point up 2. Okay, and that's k. Now let's go and focus on h. All right, so h is a horizontal shift. Horizontal shift. All right, and this is the one that kind of trips people up because, you see, if h is positive, you shift right, and that seems intuitive. But whenever h is positive, it appears negative, right? Whenever h is negative, it appears positive, and it's like, why is that? Well, let's just take a quadratic, for instance. remember that we had y equals a times x minus h squared plus k. Well, since we have x minus h, if you were to plug in a positive 3 for h, right, you'd have y equals a times x minus a positive 3 squared plus k, right? So even though we plugged in a positive for h, it was subtracted. And let's say if we plugged in a negative 2, it'd be a times x minus negative 2 squared plus k. Well, this minus a negative, that's going to turn into plus a positive. So plugging in negative numbers makes it look like it's positive. Plugging in positive numbers makes it look negative. So you have to be really conscious of that. So let's just jump right into an example with, we'll use a quadratic actually. F of x equals x plus 3 squared. Its parent, let's see, we just talked about that. That's a quadratic. And its transformation, so it looks like I have a positive in here, so it must actually be negative. And so whenever h is negative, we shift left. So this is going to be shifted left 3. All right, just like every single time, we're going to plot the parent first. And I know it might seem trivial to do this, but whenever we start having a lot of transformations, it'll benefit us to plot the parent first. So negative 2 squared is positive 4, negative 1 squared is 1, 0, 0, 1 squared is 1, 2 squared is 4. And then I'm going to shift each of these points left 3. So 1, 2, 3. Okay. And here I have my transformed function. It was translated left 3. All right, let's do one last problem. You see here we have both an h and a k. Notice h is always trapped, okay? He's always inside of the house, and k always just kind of hangs out. So what's the parent function here? Well, the parent would be a cube root. Okay, and let's figure out what the transformations were. This positive 3 on the outside, that one's the easy one. That lets us know we're going to go up 3. But what does this minus 1 say? Remember, so h appears negative, so it's positive, right? So that's going to shift us right 1. All right, so let's go ahead and plot the parent function. Remember, cube root looks a lot like cubic, it's just turned on its side. So negative 8, negative 2, negative 1, negative 1, 0, 0, 1, 1, 8, 2. Okay, now each of these points gets shifted up 3, so 1, 2, 3, and right 1. So my first point would be at negative 7, positive 1. Okay, up 3 over 1, up 3 from the origin over 1. Now, you might notice like these 3 points just kind of stayed together here. And then the final point, up 3 over 1. And then I'm going to draw my curve through the points. It goes up like that. And there we did it. We graphed with both a shift in the h and the k. All right, goodbye.